Welcome to a demo of SureMass capabilities for accurate mass. We will take a look at the properties of SureMass, including mass accuracy, of course, the SureMass ratio and what it means, and the ability to visualize those signals in 3D. So for the demo, we'll do that in Quant and show you the two shipping samples, the spiked carrot extract, which are under the GC-QTOF directory. Here we are in Quant, and I'm looking at the compound table. And let me point out, I have removed some of the toolbars to make it look simpler. I can always put those back. Here they are in the View menu. So first, I'd like to point out the dynamic range here is increased with SureMass. A couple other things. First, the qualifiers. Let me note that I did use this sample to create the qualifier ratios, so you'll see an excellent match there. Also, with the library, I have set the reverse library match score as shown in the library method discussions. So with that comparison, meaning only the ions from the library are used to create a score, you'll see some very good scores here for these level 6, which is the sample that's used in the shipping batch. So you can see I've got final concentrations for all of the 20 compounds that I'm looking at, and I can see that they all have very good calibration curves. Also, I can go here and clear results and then reanalyze, and you can see how fast that is. Let's talk about SureMass ratio and mass accuracy. So I've added those columns here, and let's take a look at the meaning of SureMass ratio. So let's take a look at the SureMass ratio. There are basically three categories. The first category is null, and that's when the SureMass ratio isn't really involved in that peak calculation, and you see those examples here. The second category is when SureMass is greater than 0. That's where SureMass is involved in following that mass, as described previously, to deliver an increased dynamic range. The third category is when the SureMass ratio is equal to 0. Now that's not seen here at level 6, but there are cases where SureMass ratio is equal to 0 and flags this outlier, indicating that the algorithm has concerns about following that mass and dynamic range. Now, best to use your calibration linearity to determine reportable results, but this case does cover the possibility of a false negative and indicates that there is a peak that could be outside that calibration range, indicating the possibility of diluting and shooting that sample to cover that concentration. In addition, you can see the mass accuracy column here, all those numbers less than 5 ppm. Let's take a look at the qualifiers. There are 2 qualifiers per target. So here are the SureMass ratios for qualifier 1 and the mass accuracies. And for qualifier 2, again, the SureMass ratio and the mass accuracies. So let's take a look at the other sample, the blank, and you can see for DDE, I don't have any signal. I do pick up some peaks from the integrator at a very low concentration. Let's take a look at malathion. There has been an integration of a peak here. The qualifier ratios are not satisfied. Let me show you a trick to look at malathion from a 3-dimensional point of view and ask, maybe there is an interference here which is affecting the assignment of a mass. So if I hold down the control key and double-click on that peak, you will see a 3D presentation. And if I expand the retention time scale, this scale here, you can see that there is a shoulder to that peak. It's certainly not Gaussian, and that could explain the mass assignment. It certainly would influence. And if I expand the mass scale, I can see I get mass separation from the nearest mass, But that chromatographic separation is not what I'm looking for in this particular case. The general principle is that this may be useful to understand what's going on underneath with interferences. Thanks for your attention.